Hello everyone, my name is Dmitro Lesnyak, and today I'm going to demo you Amazon Bedrock AgentCore implementation of multi-agent AI system. But before we go to AWS console where I can show you the implementation, let's go through solution. And the solution is that we have a collaborative multi-agent AI system that monitors, analyzes and optimizes resources across production lifecycle to reduce environmental impact. And for this I built 4 different agents in AWS using AWS Amazon Bedrock AgentCore. And the first agent is a resource monitoring agent that track consumption of electricity, water, and raw materials in real time. Then another agent is waste analysis agent that identify patterns in scrap generation and suggests process adjustments. Third agent is recycling analytics agent that calculates and track recycling rates to improve internal and external material recovery. And fourth agent is the main agent, manufacturing agent, that is a supervisor, and this agent just collaborate with all other and supervise their work. What is the architecture of this solution? Of course, everything is running in AWS, and we have main agent that runs in AgentCore runtime environment, and all other 3 agents runs in separate AgentCore runtime instances, and the main agent collaborate and use those 3 agents to get the work it requires to do done. And those agents have memory attached to them, long-term and short-term memories, and the memory are implemented using AgentCore memory service. And all agents send traces to AgentCore observability. This is used for monitoring and logging of agent, and AgentCore evaluation service is used to evaluate how agents perform in production, whether they use correct tools, and whether they give some useful information back to user. And then all agents are integrated with AgentCore gateway, and this gateway can be used to call external tools, and there are several tools implemented in Lambda. And for AgentCore gateway we have AgentCore policy attached, and those policy define which agent can call which tools. I currently have 3 tools attached to AgentCore gateway. Those tools are implemented in Lambda, and they perform different kind of actions that agents require to complete their tasks. Now let's go to AWS console where I can show you implementation of these AI agents using AgentCore runtime and AgentCore services. Now I open in browser AWS console, and I selected Amazon Bedrock AgentCore page, and in this page you can see overview what is the AgentCore. And currently I have deployed 4 different agents in AgentCore runtime: manufacturing agent, recycling agent, resource monitoring agent, and waste analysis agent. And if I open first, which is the main agent deployed to AgentCore, I can see some statistics and what is the endpoint of this agent. And the agent deployed to AgentCore have also memory attached to them, and there are 4 different memories for each agent. And if I open one of them, for example, for recycling analytics agent, I can see that this agent has 2
long-term memory strategy, semantic built-in, and user preferences built-in. And if I edit, for example, this memory, I can see more information like short-term memory can be stored for 7 days right now, and there are options for built-in strategies, long-term strategies. For example, it can summarize conversation and store them, and here is selected semantic memory that extract general factual knowledge and concepts from conversation, and user preferences. It just extracts user behavior patterns from conversation, but there are other strategies. It's possible also have override of built-in strategies. For example, you can add built-in strategy override for summarization, and here you specify what are the parameters, and what is the most important, you can specify which other model, LLM model to use, and which template, prompt template use to override this built-in strategy. It is possible also to create a self-managed strategy, which means you implement this strategy yourself. It works so that it creates SNS topic event sent to SNS topic, and then you handle the event yourself. There is also gateway used in this environment, and each agent can connect to this gateway. There are currently 3 Lambda functions attached as the target for this gateway, and if we take, for example, one of the targets, you can see what is the schema of this. It specifies which function it has and what kind of parameters like ship name and ship ID. There are currently 3 methods implemented in this Lambda function, and this Lambda function can be found if I check where is this Lambda function, and I currently have 3 Lambda functions, and this Lambda function looks like this. It deploys using Python code. In this Python code, you specify which method it got from AgentCore gateway, and based on this, it calls MCP server, which is also implemented in this Lambda function. Looks like this. And this Lambda function already have data, example data, that it uses to return results. If it is successfully executed, that it returns success code to 200, and then results as a body. If there is error or unknown function, it returns 400. And if we go back to AgentCore, in this gateway, you can see that it uses IAM permissions for inbound authentication, and there is also policy attached to this gateway, and this policy looks like this. It uses CEDAR syntax to specify what kind of restrictions and guardrails you have for your targets in AgentCore gateway. And you can see now that it permits for all principals, for all roles, the following actions. This is the list of actions from all target, all Lambda functions. So it permits call those Lambda functions and functions inside of these Lambda functions, and it is attached to manufacturing gateway, exactly that gateway. You can see that it is associated with our manufacturing gateway. There is also evaluation implemented in this. For each agent, we have separate evaluations. And evaluations means that it tests how well our agent works in production. For example, it evaluates correctness, helpfulness, and tool selection accuracy. If we try to edit this evaluation, you can see some description. Correctness means it evaluates whether information in the agent response is factually accurate. And then there are other options like helpfulness, evaluates from user's perspective how useful and valuable the agent response is. And for example, faithfulness evaluates whether information in the response is supported by provided contents and sources. There are also tool, for example, selected now, that tool selected accuracy. It evaluates whether the agent selects appropriate tool for the tasks. And you can also have custom evaluators. It evaluates all queries right now, so you can change here. Now, if we go to one of the agent and see what kind of observability we have, when you see the endpoint of the agent, you can check logs. It prints logs to CloudWatch, and also observability. There is dashboard specifically created for this agent, and this dashboard shows, for example, for me it shows for last 2 weeks. This is overview, like what kind of evaluation metrics it has, and then some latency and errors. There are also information how many sessions and traces there were. When someone calls this agent, it creates new session and it stores this session during the whole conversation. Each interaction has several traces, and they are in each session. There could be several traces. Currently, it says here which LLM model it uses. I use Amazon Nova Lite model. And here is a statistic, how many token input and output tokens were used when this agent was called, and other useful statistics. What is interesting here is, as I already said, there is information about sessions, how many sessions. You can see that there were quite many, and traces. Traces comes from X-ray, and they contains detailed informations what was interaction with the agent, different events. You can see that in this trace there are 58 events, and there is also visualization for this trace. But there is also statistics about evaluation, how well this agent was performed in production. You can see that there were 8 results for evaluating helpfulness, and then 8 for tool selection accuracy and correctness. And there were no errors for this. Here it says average score. 1.0 is that it means that all queries were helpful. If less, then there were some errors. For example, there were few somehow helpful, and most of them were very helpful. That's why score is 0.79. The same for correctness. Some were incorrect, but most of them were perfect correct. Tool selections was always right, so it shows 1.0 score. Now I show you how we can interact with this agent. I created small UI, web UI, to interact with my manufacturing AI agent. And here you can select which agent I want to interact with. I start with the main agent, and now when I try to submit query, in my query I want to get water and energy consumption for ship, and this is ship ID, and I submit this query. It takes some time to process the request, and the response will come very soon. Now it should take the resource monitoring agent. The main agent will call this agent, resource monitoring agent, to get some information. And you can see the results looks okay. Now we can try to call other queries. I want to calculate carbon footprint for another ship. Now it should call internal tool, not associated with gateway, and it returns perfect result. If we take another query, we can query different and now it returns results from agent waste analysis agent. Let's see if we query this agent directly without going through main agent, which coordinates all other agents. So it returns some text directly. Now let's go to console and see what kind of statistics we get. If you remember, we called manufacturing agent once, and we can check dashboards if there is some statistic related to it. And I would like to take 30 minutes back statistic, and I can see that there should be some sessions. Yeah, I can see some sessions. And if I check traces, let's take as example this trace, and in this trace you can see detailed information what was called by the agent, and it is our main agent, and this is description what the agent does. And I can see that the user query was to get water and energy consumption for ship 1, and it analyzed the query and decided that it should invoke resource monitoring agent, and found what is description of this agent, resource monitoring agent, and sent the message water and energy consumption for ship number 1. And it will call tool function get electricity usage and get water usage, because we need both. As a result, it will return data for ship 1 with energy and electricity, and this is for electricity. and this is for water. In the end, it will give answer to the end user.
Now let's go through key insights and best practices that I can give you based on my experience of implementing AI agents using AgentCore. And first is just reduce token usage. You can ground your queries first in this grounding, minimize token usage and lower cost, and also improve your processing efficiency. You can enhance user experience by streaming your responses to users, not wait until all response is ready and stream the responses, and this will feel that your application is very fast and your agent is very fast. Then you want to utilize IAM authentication. You don't want your agents to be called from internet by anyone. This is a security concern, but also it will cost your agent quite a lot, because LLM models are not cheap and you don't want to have unnecessary calls to your agent. Then prioritize observability from day one. Monitoring and logging is very important part that you can debug your agents, but also monitor how they perform in production. Also evaluation of how agents work and whether they use tools correctly, and so on. Then you want to mitigate hallucinations by grounding with knowledge bases. In knowledge bases you will have curated information that can be then integrated with your agent and give you possibility to return answer without hallucination. At least much better results will be expected if you use grounding with knowledge bases. In the end, I just want to tell you that unlock the power of enterprise AI agents and get hands-on with AgentCore today. It is a very easy to use service, but this service is very useful if you don't want only to have prototype or example, but if you want to build AI agent for production. Thank you very much for your attention. I hope this demo was very useful for you. If you enjoyed this video, hit the like button and subscribe for more content like this. Thank you very much.